Now let's take a look the construction of FET. We have here the first one is the junction FET, and then the second one is the depletion type MOSFET. The third one is the enhancement type MOSFET. Okay, now can you see any difference between these three transistors? Of course, you can see junction FET has much different compared to these two. And the MOSFET actually, if we see that here is almost similar. Okay, now we go back with the meaning to the meaning field effect, where we refer to the electric field established by the applied VGS. Okay, remember that for the VGS here. The electric field is originate from the electric charges. So for the JFET or junction FET, the meaning of the junction, okay, refer to two type of materials which are P and N type. Okay, P and type material that attach together. Here, the P and N attach together, and automatically there is a depletion region in between this material. Okay, refer to your analog 1 knowledge, okay, where you learn about this in semiconductor and also in diode. Okay, the process or the mechanism is similar, and you apply that knowledge for this junction FET. So where we can see this P and N, okay, here you see at the G, at the gate, there is a P type and also P type at the left and right side. Then at the center, at the body here, the center body, that this is the N channel where the current or the electron flows. Okay, so at the gate, it will control the amount of current or electron by closing or open the gate. Okay, so we have D terminal, drain, we have G, and we have S. Now we go for the meaning of the MOSFET. So what is MOS actually? MOS refer to metal oxide semiconductor, where the metal is actually a metal contact at drain, gate, and source terminal. Then the oxide semiconductor is the silicon oxide, which is an insulator at the transistor. Okay, take a look now. Where is the metal contact? Here. This is the metal contact. Okay, this is the metal contact at G, metal contact at S, and metal contact at D. Same goes to enhancement type. Okay, for both depletion and enhancement type has the same metal contact, and the silicon oxide also at the middle, okay, in between the metal contact and the channel. Okay, so here the green color is the silicon oxide. It works as a insulator. Okay, and please take a look carefully. At D there is a small gap. Okay, small gap here. So the silicon oxide is not covered this area. It's open area here. But for the G, okay, there is a silicon oxide. Okay, I will explain later why it happened. And the difference is D and G and S here. Okay, so take a look the meaning of the depletion type. Why we call it depletion? Because this transistor has a channel at the beginning. Yes, you see, depletion type has channel, but the enhancement type, there is no channel. So at the depletion type, the channel will deplete when the transistor operate. Means that when it on, okay, this channel will reduce. Okay, will be reduced, or we call it will deplete. Okay, compared to the enhancement type, At the beginning, there is no channel, but the channel start to grow or develop when the transistor is operated. So it has the opposite process from the depletion type and enhancement type. You have seen the construction of JFET, DMOSFET, and eMOSFET. And now, what are the differences between JFET and MOSFET? Can you figure out? Okay. The difference between these two, JFET and MOSFET. Number one, JFET has PN junction materials and it has no metal contact and no silicon oxide. Okay, this is a major difference between JFET and MOSFET. So you can say MOSFET has metal and also it has silicon oxide. What is the similarity between the JFET and MOSFET? Okay, the similarity is the number one, both transistors have same terminals, drain, gate, and source. Number two, there is no current between gate terminal and the N channel. Why? Okay, why there is no current at G? Okay, this is because for JFET, there is a large depletion region between the N-type and P-type materials. So, this is because of the reverse bias happen during this time until the pinch off occur. Okay, you will understand, okay, this one when I explain it in detail for the JFET. Okay, then for the MOSFET, there is silicon oxide layer, which is the insulating layer under the gate terminal contact. Okay, so these two are the similarity between JFET and MOSFET. It means that for the number 2 means that there is no current at all at G, or we say that IG equal to 0. IG here equal to 0.